Hi everyone and hello, welcome to this video. So last time basically we left off with our triangle, we covered shaders a bit, and this time I promise that we're going to do memory buffer, and we're going to get to that, and we're going to get the presentation part. But before that I just wanted to make a couple of fixes that are going to make our life easier going a bit forward. And there are some things that I forgot. For example, I never released this shader module or the pipeline. So what I want to do is, just so that our life is a bit easier in the following videos, I'm just going to move some stuff around. And first thing that I'm going to move is this create shader module, and I'm just going to create a new folder, and I'm just going to call this utils. So very generic, but here I'm going to create a new class, and I'm going to call this one shader module util. Shader module util. So you're going to see what I mean here and what I want to have. And here I'm just going to make this public, and then we're going to need to make it unsafe. And I'm just going to say public shader module, and then the pointer, right? And we can just say create here, and the parameters that we're going to need are engine. So we're going to need string, and we're just going to say file path. And then from our unlit render pipeline, we can just copy all of this code and move it here. So this is fine. It's just going to be called, let me copy paste this, it's just going to be called file path. And we probably don't need this, and we can just return it. And that's it regarding this class. I'm just going to perform a bit of cleanup here, and then what I'm going to do is create another class, and then I'm just going to call this one WebGPU util. So it's going to be public. I think we need to make it unsafe, maybe even not, but I'm just going to call this shader module, and it's going to have a getter, but we're just going to initialize it like so, and it's going to be static. So now what we can do is this. We're not going to have this create shader module, right? We can just create it here. We can say WebGPU util dot shader module dot create, and then we can paste that engine and then the file path which I copied, and we can paste it here. So at the end here of this initialize, we can just get rid of that shader module. So I'm just going to say engine view shader module release, and then we pass in that shader module. So I'm just going to say dispose of shader module. And then very similar, we're just going to do same for the pipeline. So I'm just going to copy all the pipeline code. I'm just going to call create a method and the pipeline util. It's going to be public, probably needs to be unsafe. Render pipeline pointer, and we can just say create. So we're going to need engine once again. We're going to need that shader module, and then for the rest of parameter we can check. So this vertex function can be a parameter, so we can say string vertex function name, and we can have default. So it's probably good if we just have default, and then we don't have to think about it, as long as we follow this pattern in our shader, right? If you remember now shader, our vertex function was called main. We asked for vertex shader, and then we had main fs for fragment shader. So we can just reuse that pattern here. So we can say here as well, string fragment function name is, you can obviously rename them as you please, but I'm just going to use this because that's the pattern that I like. Fragment function name. What else do we need to move here? actually nothing. We can just return here and everything else remains the same. So here, let me just get rid of this quickly. We can do the same thing here. We can just say public static render pipeline util render pipeline get, and then we can just initialize it, and then in our only render pipeline class we can get rid of all of this, and here we can just say WebGPU util render pipeline create engine, and then we pass shader module, and that's kind of it. And one other thing, I just want to dispose of this, so we need to implement disposable pattern. And then we can say here engine.webgpu render pipeline release, and then we pass render pipeline. And finally we just need to release those resources. So our engine is just going to have a new event somewhere where we had event here. So we're going to have another one, action on dispose, right? And whenever we're disposing of an engine, so somewhere over here, we can call .dispose.invoke. That's good. And in our program, then we can now say engine on dispose plus equals and then only train the pipeline dispose. And let's just see if it works now. There are some build errors. Using clause here. Okay, that's it. And it works. And if I quit, there were no errors, therefore we're good. Okay, that's it regarding this part. So I just want to do cleanup before it gets too messy, so that we can have easier workflow in the future when we need to create new resources. With that said, let's jump to our presentation part. So what we're going to cover is passing that data to GPU, right? Last time, if you remember, we just hard-coded some values in the shader, and we want to avoid that. So how can we do that, and how can we send that data from the CPU? Well, we create a GPU buffer, and GPU buffer, WebGPU buffer, is just an interface that represents some block of memory that can be used to store data to use in GPU operations. It can be a shared memory, but also it can be CPU memory where contents are copied to from GPU as needed. So in a nutshell, it's just some slice of memory with some data in it. With these buffers, we're just going to cover in this video per vertex data, and we're going to cover the rest of the data formats a bit later. So the other formats are instance data and then basically global data. So we're going to cover that in the future. But per vertex data, we pass for each vertex. So that means we last time had triangle, right? Triangle has 3 vertices. So for each one of those, we're going to pass some data in. That's going to be position in this video and a color. And you're going to see how it works. So we just need to know about WebGPU layout, which is basically how we describe the data. We're going to get to it in the video. So it can be passed as an array of structure or structure of arrays. What that means is this. So if we have basically structure of arrays, let's say that these are positions and these are colors, right? We're passing red here, right? Green here, and then blue here. And these are positions, so minus 0.5, minus 0.5, right? These are just basically positions of our triangle. Maybe I can draw it so that I can explain it better. So as you can see, let's imagine, and Z here is ignored. We don't care about Z yet, but I just excluded it for simplicity as well. So we have minus 0.5 here, and then minus 0.5, right? And then we had this other one, which was 0.5, and then minus 0.5, right? And then we have 0 and 0.5, let's say. So basically we pass in this, right? But here in an array of structures, you can see that our position is here, it's here, and it's here, right? But how does this work? Well, basically with structure of arrays, you actually pass in data as two arrays. But in array of structures, we can pass all of the data as one array and just basically have this as a v1 struct. Then we can have this as v2 struct and this as v3 struct, right? And here I wasn't paying attention to the colors, but obviously we had here red color. So basically this one first would be red, this second one, actually third one is blue, and right, so this corner will be blue and this corner will be green. So you might be wondering how this is going to work out in the end, and you're going to see it. Basically the WebGPU is going to linearly interpolate between these colors. So basically it's going to go from red up to the half, and then it's going to go towards the blue color. And you have to see it, and then you're going to understand it. But basically then these colors, right, were here pasted as red, but they correspond to this here, these were pasted as green, they correspond to this here, this. And regarding the data format, we're going to use this one, array of structures. It's just a bit easier, and you can do this one, for example, for your you can do it in your free time. It's very easy to understand once we do this one. Okay, so that's it regarding the presentation part. It was very quick, but let's get to our shader. So here we don't want to hardcode these values anymore, so we want to paste them in from the CPU. And how we can do that? Well, we can create a struct and we can call it vertex shader input. So what did we mention? We're going to have position, and here I'm going to explain these locations, but we're going to have here location 0, and we're going to say position. And in presentation I kept vector 2, but here we're going to actually use vector 3, and for color we're going to use alpha channel as well. So it's going to be vector 4, but here we're saying location 1, and it's going to be color vector 4f, right? And then we need to have output from the vertex shader. So we're going to have output, and here we had built in position here, so we're just going to move that out, right? So you can either pass here a variable, right, but you can also pass a struct out. So we can say vertex vs output for vertex shader output. So we can do that, and here we're just going to need then to give this a name, and it's of vector 4 type. And then to fragment shader we're going to pass that color out as well. So at location 1 color. So basically, to summarize, this built-in position is kind of like location 0, but you always have to use at least pass position, right? Otherwise vertex shader is invalid. And here these are inputs, and we're going to cover these locations, but this location, it just means kinda it's part of this layout, right? You need to describe your data in, and we had this idea of structure of arrays, array of structures, but it's not that relevant. We just kind of need to say on the CPU side, okay, we're going to bind this to location 0 and then some other data to location 1, and you're going to see how it works. But let's fix this. So here we're returning output, and this built in. So I'm just going to make a bit of spacing here, so it's a bit easier to understand. And then we're going to have in vertex shader input. So we can just pass input here, and then we can say var out vertex shader output, right? And we can just assign those. So our input position is vector 4, right? If you remember, this needs to be vector 4, right? But this is vector 3, so we just need to create from our in position, and then last argument can be 1.0. And my apology here, this is probably too small. I haven't noticed, but let's try to zoom in a bit, and then we have color. In that color, right, we're just assigning to our out variable that color, and we return out. So here, what's going to be input in our fragment shader? Well, the output of vertex shader. So vertex shader output, and I'm just going to create a bit of spacing here, and instead of red here, we're just going to return in.color, right? So whatever we pass from the CPU, from our C# code in this color, we're going to use it as our output of fragment shader. All right, that's it, but let's start with describing that layout. So how do we describe that layout? So basically what we need to do is on the CPU side, right? We need to describe that layout that's in our shader. And we do that with this vertex input state. So here, if we take a look at the attributes, here I think the vertex state, the buffers, right? So that takes vertex buffer layout, right? So we're going to create here vertex buffer layout. So let me just see how I'm going to do that. So we can say layout, new vertex buffer layout. And here layout, what does it take? Attributes. Basically, let's just fill in stuff that we know. So step mode, it can be either vertex or instance. And instance we're going to cover in future, but for now it's just vertex. So what else can I fill in? Step mode, attributes count, array stride. I'm going to cover array stride, but let's create these attributes. So attributes, kinda what attributes are going to describe are these things here, right? We have this attribute and this attribute, right? The part of our struct. So basically we can describe it. So let's do that. We can use here stack alloc, and then we have two of them. And so we can say here vertex position. So, okay, vertex attribute, we can say 0 dot. So we need to pass in format. And if you check the formats, you're going to see all of this float 32, 32, 3. So we care about this one, right? Why? Because we're using float, and float has 32 bits, right? And we use times 3 because here, sorry, here it's vector 3, right? Of type float, and it's vector 3. So we use here, right? Here in the pipeline, we use float 32 times 3. So further, what do we need? We have shader location. So it's going to be 0, right? Why? Because it corresponds to location here. All right. And then we further we have electrics attribute. Sorry. So what else do we have? Format, shader location, offset. Offset is just 0. We don't have any offset for now. So we can say vertex color. And here it's going to be very similar. So I'm just going to copy this, and I'm just going to say 1, 1, 1. So now shader location here is 1. Why is it 1? Because it's 1 right over here. So pay attention here. It's vector 4. So we just have to change this float 32 times 4. And offset, we have to offset for the bytes here, right? If you remember, I mentioned that we're using array of structs. So what that means is our data is laid out something like this. Let me just do this. It's smaller, even smaller. All right. So what we basically have is this vertex, right? So let's say that we have 3 of these, right? So for X, right, position, Y and Z position, and then we have here red, green, blue, and alpha, right? And that describes our vertex. So we have 32 times 3 here, right? That's this part. And then we have 32 times 4. So the offset, where does this second one begin? And that's color, right? It begins here, right? So this offset is we have 32 bits, right, per basically component times 3, right? But we don't care about bits actually. We want to paste it in bytes, and 32 bits is 4 bytes, then times 3. So our offset in total is 12, right? So we can just paste 12 here, and then we're done with it. So let me remove this, and then but there is a better way of doing it. We can say size of float times 3, and that's going to be 12. Alright, so we can paste that vertex attributes. What did I call this? So I think it should be plural probably. So I'm just going to say rename, let's say attributes, and we probably need to paste count as well. So attribute count is 2. And I think that's kind of it. We just need to paste that buffers here. So we just paste layout here. Oh, sorry, pointer to the layout. And let's just see if it will compile so that I'm sure that everything works as expected. So we have some error. Let me check what it is. Where are you? So here. Okay, we just haven't provided any input data. Okay, cool. All right, that's fine. That's fine, because we're going to do that now. So for this one, I mentioned earlier that we need to create a buffer. So I'm just going to create a small class here. Sorry, first directory, and we're going to have different buffers here. Planning about something, maybe I misspelled something. I did. Okay, and we're going to create a new class, which is just going to be vertex buffer. So here, I'm going to do a similar thing here. I'm just going to create util class for creating a buffers. So I'm just going to create, call it buffer util. It's going to be public unsave class, and then we can say public. So buffer create. And here I think we're going to have a bit of an issue, because buffer here is from the system.buffer. So we kind of need to use an alias. And what I like to do is here, because we don't want to use it from the system, I just can create alias here, WebGPUBuffer. I'm going to call it like that. And it's this .NET, right? Our namespace, WebGPU, and here we have buffer. So we can just use alias here because the buffer is already used by system. And then what else are we going to need? Buffer, we're going to need that data, right? So bear with me. So here you can just say engine, GPU, buffer, device create buffer. I think it's like that. Is it not? Buffer, buffer, buffer. Device. Here. So what do we need? We need device, engine, device, and then we need buffer descriptor. So let's create one. So let's look at the parameter. So we can map it at creation, and I'm not going to do that because it might be useful to take a look at that another time. But there is easier way. Mapped at creation, it means that we kind of need to create a middle step and then create a CPU buffer and then copy specifically to the buffer that's assigned as a GPU buffer. But here we're just going to create a GPU buffer and then copy data to it. So if you want to map it at creation, it means creating two buffers, which sometimes it makes sense. Here I don't want to do it, so I'm just going to say false. Buffer, then we're going to need size. What's going to be size of our buffer? So I'm just going to do this because I'm going to need size later on. So here it's going to be data.length times size of float, right? And I just need to cast it to uint, because this one takes size as uint, so not here but actually here. And then buffer descriptor usage, sorry, and this should have been called descriptor. All right, descriptor, and here, so buffer usage. So we need to describe how this buffer is going to be used. So it can be uniform, it can be vertex storage, and here index, and that's all data related, and we're passing data per vertex, so it's going to be vertex buffer. And the second one that we need is just to say buffer for usage copy destination, so it means that we can copy to it. All right, so basically when you assign buffers, they can be CPU buffers, GPU buffers, or shared buffers. All right, and that means there is some logic on how can data be transferred between them. We just want to copy this buffer and send it to the GPU, so we're going to do that. And that's it regarding the descriptor. So we can just create a buffer, and here we're just going to say buffer, and it's a pointer, but it needs to be here, right? So all right, let's see what did we do. So we said we're not going to map it with creation. That's fine, because we're going to write right now to it. We just specified size and its usage, but we never pasted data in, right? We just used it to set the size of the buffer. So now is the part where we need to paste the data in. And so here is a new C# keyword, and it's this fixed. So this might be confusing if you're not used to unsafe C#, but fixed means that this data cannot be released by a garbage collector until it's in this statement, right? So it just means, okay, we can get pointer to it. It's not going to be released by garbage collectors, therefore we can use it. All right, so now how do we write it to that buffer? Well, we use WebGPU queue, right? We need to queue it. Queue write buffer. We have this method, so we can say engine, and we don't have queue. All right, so we're just going to need to do one more thing in our engine, similar to what we did with the rest of this, right? The lights WebGPU preferred format. We're just going to do this, make it public. Then I can rename it, right? Because it's public, I'm just going to rename it to queue. And then we can say get and private set. And then it's going to be available right over here in buffer util. So we can say queue. We can pass buffer in. Buffer offset is 0. Our data is data pointer, and then we have size as well, right? So we don't want any offset. Data pointer, right? It's just pointer to our data that we paste in, and then size is the size of our buffer. We want to copy until position 0, and from position 0 until the end, and that's it. And then we just need to return our buffer. Okay, and we can create it here. Public static buffer util buffer. No suggestions. Thanks. All right, I think we're good. So we can get to this vertex buffer, and here what I want to do is I just want to paste per vertex data in vertex buffer, and then we're going to have buffers for different types. But here, so we're going to need our engine, private read-only engine. We're going to need constructor, public vertex buffer. We paste that engine in. We assign the engine. We're going to have public. So I need to do this same thing, right? Because this is probably going to have namespace collision. So So we can just return that buffer. It's going to have get and private setter, and then we're also going to need size. So I'm just typing this out a bit early, but here we're going to have initialize, and then we can paste data in. Right? This is just a wrapper class essentially. So we can set up size. So it's going to be uint data length times size of float. And then for the buffer, WGPU buffer create. So what do we need to pass? Engine and that data in. So we have created that buffer, and it's important. We just want to be able to dispose of it. So we're going to implement this interface. Here I'm just going to move it. And here we can say, what can we say? Engine destroy buffer. Here buffer destroy, and we destroy that buffer. That's how can we destroy it. And with that said, we can actually try to create it finally. So let me just see how are we going to do it. Okay, so in our program, but we haven't pasted it to the GPU yet. So here in our render function, what I want to do is just, I want to have, so how are we going to do it? You know what, let's just paste vertex buffer here. Buffer. And here, after we set our pipeline, we can set that buffer. So we can have engine, GPU, the pass encoder, set vertex, here. So it's kind of long, but we're in the pass encoder, set vertex buffer. So we need that current pass encoder, right, that we had. So let me just take a look at the parameters. The second one is slot, and it's first buffer, so its slot is going to be 0. So we can say buffer, text buffer offset, and then this is the reason why I had this size. We can just set size here, and here it's not vertex buffer, it's actual vertex buffer. Right. So here the location also corresponds to actually buffer location. So we have described our buffer as this, but if you have one buffer for this and one buffer for this, you would have to pass in 2 buffers, right? And then set up second buffer at location 1. So that's the difference. That's why I wanted to pass in data as a array of structs, because it's easier, right? It's a bit harder to understand, but it's easier to work with, because I don't have to manage 2 buffers, right? I can just pass 1 buffer and that's it. And here in our buffer util, sorry, not here, in our render pipeline util, if you wanted to have multiple buffers, you would have to describe second one, and then each one would have 1 vertex attribute, right? So you can play with it like in your free time just to try to understand it, but this is how I went with it, and it's my approach that I like to take when I write something. Just have 1 buffer, it's way easier to work with. With that said, let's just try to see if all of that works. So in our program, we have render, but we haven't created buffer yet. So we can just say here vertex buffer, vertex buffer. We paste that engine in. We need to initialize it. So here we can paste that data in. So we're going to have minus 0.5f, minus 0.5f, and then 0f for z, right? And then colors, we can just paste red, and then alpha is going to be 1. And here I'm just going to say b1 for the first vertex. And here I need comma. So very similar. We're going to have almost exactly the same for second vertex. It's just going to be positive x, so 0.5 here, this remains the same. The color, I just want green for the second one, and then let's pass in the third one. Here this one is a bit different, because here for x we want 0, but for y we want 0.5. And then it's not going to be green, rather we're just going to paste blue color in. PG, I don't need comma here actually. And then we can paste that vertex buffer, and finally we can dispose of it. And if I try to run it, hopefully it will work. It doesn't though. Okay, something went wrong. Let's just see what went wrong. Can I get somehow the... So here... Okay, this is a bit weird. I have an idea. So, okay. Alright. So I copied all of this. Ran the pipeline here. Let me just see for a second. So this is fine. Our unlit copy newer. It's copied over. This is good. Okay, and then here, comma is not supposed to be here. That's probably fine. Let me just see once again. Ran the pipeline util. So I paste in that layout. Let me check my code on the other side. So this is fine. 0, 0, size of 4 times 3, location 1. Aha. So one thing that I'm missing is array stride. So what's a stride? Well, if you remember when I draw this basically array, we had 3 positions for, well, basically our position x, y, and z, and then for the other 4 colors, so red, green, blue, alpha. So we just need to take that, which is 7, right, times size of float. And I think that's the only thing that was missing. Not yet. Okay, let's check other stuff as well. All right, my bad. Here, vertex state buffers count is 1. So we have 1 buffer. That was missing as well. Something is still off. Okay, my bad. If we check the error now, we get this error invalid queue. And why is that? Well, it's because we initialized this buffer before we fetched the queue. So we were passing invalid pointer. And if we take a look at here, so we were basically fetching our queue here, right? But we also need to fetch it when we initialize stuff around. So basically before we call initialize callback, which is right over here. So we can just say this here, right? We can fetch queue here, and then if I try to run it, it should work. And it kind of works, right? It actually works. So let's just recap this real quickly. So basically what we had is we kind of created our data, right? And I mentioned that our vertex is going to be x, y, and z, right? And then we had colors R, G, blue, and alpha, right? And then we had this second time, right, for the second vertex. So that's how we described it, right? X, Y, Z, and then 3 dots, right? And this was all vertex 1, which belongs to this vertex here, right? Then we had this one, which belonged to vertex here, and then somewhere the third one, which belonged to vertex here. So basically, because we assigned, let's say, blue here and green here, it actually linearly interpolates between the colors. So here is the middle where they meet, and here it goes from red to green, and then basically here it will be combination of red and green, right? They will be both 0.5, and then as it goes here, the green becomes more prominent and less red one becomes less prominent. So that's how how it will solve that. So basically it's just going to linearly interpolate between the calls. So that's how every graphics API is going to solve for that. Further, what we did is in our shader, right? We defined our vertex shader input, that position, that color, vertex shader output. We paste that in. So this is also something that we learned, how we can paste data to our fragment shader, right? We paste in color here and then used it here. Another important thing to mention is this tricky part, right? We had to describe that layout, and you always have to describe that layout, right? Because the GPU has no idea in what format it can expect your data to be. And then we just created the buffer, which was actually relatively easy, right? We just created the buffer and then used Q to write to a buffer. And that's it. So that's it regarding this video. It was a bit tricky, but maybe try to do it yourself, right? If you just manage to do it yourself, it's going to be very clear how it works. For the next video, we're just going to maybe do index buffers and try to draw something else that's not a triangle. Usually it's a quad, right? So we just have to understand how can we draw models, not just triangles. Okay, so that's it for this video. If you liked it, maybe like, subscribe, and until next time.